Continuing on, we're going to talk about the usage of meters on hybrid vehicles, and mainly the main thing you need to know is when you're working around hybrid vehicles, you need to be very, very careful. They do have some high voltages, as high as 650 volts of direct current. That's a lot of voltage. Okay, so we want to be real careful when dealing with hybrid vehicles, and we want to use over voltage protections, and they got to be rated Cat 1, Cat 2, Cat 3, and Cat 4. These are over voltage protections. Okay, what do we use on a hybrid? Be sure to use only a meter that is Cat 3 rated when taking electrical voltage measurements on a hybrid vehicle. Cat 3 rated. Okay. Make sure you see that when working on a hybrid vehicle. That ensures that you're protected against that voltage shock that could result from that. Alright, let's look at some digital meter usage. Okay, this guy is, well, we're going to have to follow along in our book. Might be a little bit too small to read. So I'm going to blow this up and go with you step by step through what's in your book. In step 1, they talk about the digital meters that can often become tangled. Okay, so we want to start by straightening up the leads. Another thing you'll see quite a bit of is a technician tying a knot in the leads near the end, and this helps them prevent becoming tangled. Okay, for most electrical measurements, the black meter lead is inserted into the terminal label COM, and the red lead is inserted into the label number V. So here's what I'm doing. If I'm going to measure voltage, I'm going to put the black lead in the COM, or common ground, and this lead is going to go here to measure voltage. Of course, this is my red lead. Alright, now I also measure ohms in the same position. So volts or ohms I'm going to measure here. Okay, over here I've got one that is a milliamp, and here I've got one that's an amp. Now this meter, I can't read it, but it may be rated probably somewhere around 10 amps. Okay. So what does that mean? Well, you know, a series circuit has to be connected, or a amp meter has to be connected in series. Okay, so if I got this meter connected in series, I basically got it connected like this right here. Now these meters are internally fused. And if they have a milliamp scale, usually they're fused somewhere around 200 milliamps, and they're fused around 10 amps. So the most we can measure on a circuit is 10 amps, and this has got an internal fuse. Okay, what's that mean? Before it will burn this meter, if I try to run 300 amps of current through that meter, something's going to fry. Okay, but what ends up happening is it's got a fuse on the inside. Let's say that fuse is 10 amps. So more than 10 amps of current flow through that meter, that fuse pops. We got to take our meter apart and replace that fuse to measure amperage again. You'd still be able to measure voltage in ohms, but the amperage meter wouldn't work. So whenever you're measuring amperage, you want to make sure that it's below the rating of that fuse, what you're measuring. We'll talk about that more as we go along in this, but that's really a key there. The next thing we want to do is to turn the power switch on and select the unit of electricity to be measured. Now right here, he looks like to me he's measuring, and it's really hard to tell, but it looks like to me he's got this thing centered on either the DC or AC voltage scale. We can tell these apart. DC is going to look like this right here. Okay, AC is going to be denoted like this right here. So one's a sine wave, one's a straight line over a dash line. So this indicates DC, this indicates AC. Now this one says for most automotive electrical, select DC volts. So you're looking at the voltage one that looks like this, or DC volts. And for most automotive electrical use. Now that's why I've been trying to get you guys used to voltage drops, because that is going to be that's going to be the biggest measurement, the most often used measurement. Now in step 7 they're telling us to connect the red meter lead to the positive terminal of the battery. So let's say I'm looking down on the battery and I've got my red meter lead at the positive terminal, and I'll connect my black meter lead to the negative terminal of the battery. Okay, what should I read? I'm going to read the difference in potential between these 2 points. So that means over here I've got 12 volts. It should be a 12. Over here I've got 0 volts. So what I'm going to read is 12 at the red lead minus the 0 volts at the black lead. I'm going to read 12 volts. So when I hook that to the battery, you'll see this thing go to 12 volts. They're showing you here figure on step 8. They're showing you the reading on a battery, and you need to pay close attention up here. And this is 13.15 volts. So this is probably the battery on a running car. A normal healthy battery will have 12.6 volts present in the battery. Once we start the car up and the alternator kicks in, we should see somewhere between 13.5 to 14.5 volts. Okay, and we see this is volts DC. We don't see any kilovolt scale or megavolt scale or anything like that. Okay. So let's move on along to the next slide. Resolution is another important function of a meter. And you can see how the difference is in these meters. This one won't show that other digit, okay, or it won't read as accurately as this one. This one will show it right down to the thousandths of a volt by adding another digit over here, where this meter stopped at that point. So this Fluke 89, which would be on the right compared to the Fluke 87, well, this will only display those four and a half digits. This will display 5. This will display 5.5 digits. This will only display 3.5. So that's your difference in resolution on the meter. Now these meters are measuring the same reading but on different scales. Okay, here you're looking and you can't read it too well, but it would tell you somewhere that we're on the 20 volt scale. Now keep in mind this is a half a digit. Okay, so we got a 1, 2, 3, 4.5 digit display. What that means is 4.5. I can display one digit here, one complete digit, a 0 all the way to a 9. But down here in this position, I only have 2 spaces, so I can only display a 1 or it'll be blank. Okay, so on the 20 volt scale, the most I can read is 1, 9, right? So once I get to 20 volts, this can't display a 2, so the meter is going to read OL out of limits. Or I can go to a larger scale, like the 200 volt scale. Okay, now I can read from 0 to 200 volts. And you see at 13 volts, which you can measure on a 20 volt scale, it doesn't give you as accurate a reading. But this scale is not going to read something like 140 volts, where this one would. Okay, so you trade off, I guess, accuracy for size and vice versa when you're changing scales. So make sure that you're paying close attention to what scale you're on as you're using these meters. Another thing you want to be real careful of is this meter can read your body resistance. Okay, so you want to make sure when you're ohming something that you keep your hands away from it, because you're going to measure the resistance through your body, which is going to throw off your reading in the scale. Let's take a look at the next page. Okay. Okay, a meter set on ohms can be used to check the resistance of a light bulb filament. In this case, the meter reads 3.15 ohms. If the bulb were bad, the meter would display OL. It would say out of limits. What's that mean? Well, that means that this bulb, if I were to take and look at it, that filament inside there is broken somewhere. Okay, so when I see OL, I'm saying, oh, well, I'm connected here and here, and the electrons that I'm sending out this wire, they can't get back to this wire because they stop right here. So I'm out of limits. Okay. There you go. I've written important up here. Important. If you're measuring anything, be sure to read the meter face. In this case, you see kiloohms, right? Which that indicates that we're making this measurement in K 1000 ohms. So even though I'm seeing 291.10, I'm actually talking about 291.10 kiloohms. That means I've got 291,100 ohms. So always pay attention to that scale, or else you're going to come up with some bad readings. Looking at this, I'm looking at a sail beam headlamp bulb. It's showing I'm measuring about 1.52 ohms. The only symbol in the window is the ohm symbol, and it's hard to see that. You may can see it a little better in your book. So it's showing that if I see that ohm symbol, it's actually showing the resistance in ohms and not kiloohms or mega ohms. Okay. Okay, this other filament reads 3.53 ohms. Okay, when I'm reading the 3.53, I notice there's no kilo or mega, no prefix in front of it. And it says here, well, obviously this filament is the low beam. High resistance means less current flow and a dimmer light, right? So your highest resistance is always going to burn lower because high resistance equals lower current. In this unit, we're measuring AC current, and we're showing 119.76 volts of AC, or you'll see it denoted like that. Okay. So we can also use it to measure AC voltage. Let's summarize what we've learned. Okay, a digital multimeter and digital volt ohm meter, or ohm milliamp meter, are terms commonly used for electronic high impedance test meters. We talked about high impedance being the internal resistance of the meter. Use of high impedance is required on any computer related circuit or component. It avoids meter loading, and you should know what meter loading is at this point. Amp meters measure current and must be connected in series in the circuit. Voltmeters measure voltage and are connected in parallel. Ohm meters measure resistance of a component and must be connected in parallel with the circuit or component disconnected from power. Logic probes can indicate the presence of a ground as well as power. Okay, so we talked about all that stuff. Okay, you got these questions at the end of the chapter, and I'm going to ask you to answer these this week. So if you have any questions, please feel free to contact me. All my contact information is right here for you. My email, my phone, my office location, and my Skype address. So if you're looking for me, you've got 4 different methods you can reach me, and I'm always here to answer any questions that you might have. Alright, thank you, and I wish you good luck this week.